this video, we are going to be solving dx equals c by Gaussian elimination. So let's take a quick review of what Gaussian elimination is. We'll start by setting up an augmented matrix of d and c, and let's do that now. So that'll look like this. We'll put the matrix D on the left, add a line in the middle to separate them, and put the vector C on the right. So the process of Gaussian elimination will be trying to get this left side down to reduced row echelon form. If you recall, reduced row echelon form is a simplified standard form of a matrix where all 0 rows are at the bottom, every leading non-zero entry or pivot is 1, and each pivot is the only non-zero entry in its column. The way that we achieve this is by using these 3 strategies in combination with each other. So the first strategy is multiplying or dividing both sides of an equation, like this left component and this right component, by the same number to maintain the truth of that statement. We're also able to change the order of the statements, like we could swap equation 1 and equation 2. Additionally, our third strategy is that we can add or subtract 2 of the 3 statements, and that will yield another true statement. So let's see what that looks like in practice. Now remember, we're trying to get it into reduced row echelon form, so it'll be a lot of adding multiples of an equation to get 1s and 0s. For example, let's start by trying to get rid of this 4 and turn it into a 0. To do that, we can take equation 3 and subtract 4 times equation 1 and write that in equation 3's place. This means that equation 1 and 2 will carry over. And now we'll take 4 minus 4 times 1, which will be 0, 0 minus 4 times 2, which will be negative 8, and 2 minus 4 times 0, which will be 2. And you have to do the same for the other side of the equation, so 3 minus 4 times 2 will be negative 5. Now let's get this 3 down to 1, since that will be our pivot for the row. To do this, we can simply divide equation 2 by 3. Let's transfer over equations 1 and 3. And divide each of these elements by 3. For our next step, let's get rid of this negative 8. We'll do this by taking equation 3 and adding 8 times equation 2 to it. So let's transfer over equations 1 and 2. And now let's add 8 times equation 2 to that. So that will give us 0, 0, 14 over 3, and negative 5. Now, we want this 14 over negative 3 to become a 1, which means we can multiply equation 3 by the reciprocal to make that a 1. So 3 over 14 times 0 is 0. 3 over 14 times 14 over 3 is 1, and 3 over 14 times negative 5 is negative 15 over 14. And now we'll focus on getting this 1/3 to a 0. So to do that, we will subtract 1/3 times equation 3 from equation 2. That will simply give us 0, 1, 0, and then 5 over 14. So now we're super close. All we have to do is turn this 2 into a 0. So to do that, we're going to take equation 1 and subtract 2 of equation 2 from it. So I'm just transferring over equation 2 and 3. And now we'll have 1, 0, 0, and 9 over 7. And now you can see that this matrix is in reduced row echelon form, which means that this is our x.